I want to discuss a concept important in object-oriented programming, and that's the concept of UML. Let me make this a little bit bigger. All right. UML, which stands for Unified Modeling Language. And it's not really unified. It doesn't model anything, and it's not a language. So why they call it UML? Well, there are reasons behind it. It's a blueprint, and when you look at this blueprint, you can take it and translate it to any language that you're working in, regardless of the syntax, regardless of any of the different ways that they manifest object-oriented programming and design. So if I was to look at a UML of the point object, let me create it, let me insert a table, and come on, table. I want a table with just 3 rows, 1 column. UML comes in 3 pieces. The first is the name of the object. The second one is the attributes, the private members. And the third are all the different functions or methods. So this one is called point. Okay, so let me put the point there, and we'll center it. Okay, so when you see a UML, it's got 3 phases. Because I'm going to give you a UML for the lab, and your job is to take it and build it. And again, UML is this blueprint that you can take and use in any language. So the first area are the attributes. So if I wanted the private x and y, I write it like this: minus x colon int minus y colon int. I'll put some spaces between these. Again, I said it's not unified, so it's very flexible. Sometimes you see it with or without the spaces between the colons, sometimes not. Again, it's not unified across the board, but if you look at this, you can say, aha, I'm going to create an integer that's going to be private. So here we create variables, and we would say int x semicolon if we're in C++ or Java. You would say var x if you're using Swift. If you're using Visual Basic, which has a very poor object-oriented system to it, but one nonetheless, you would say dim x is integer. So by you seeing this, you know in your language how to create these variables of those data types. Okay, and that's all we have, just these 2 private methods. Here now are the publics. So you put a plus for public, and we have the point object with nothing in it. And I'm going to put a little space there, that way it doesn't look like a big fat O. All right, a point object, that's our default constructor. When we see that, we know there's a default. What's our default? Well, that UML doesn't tell us. We, the programmer, need to know what the default is. We also had a point object that took in an x and a y. Again, using the same template from above. X is an integer, and y is an integer. Okay. Then we had the setters and the getters. So we would say this: plus set x, and we want to take in some x to set the x. And it doesn't return anything. Sometimes in UML they put a void at the end as the return type. Again, a language like Visual Basic would put the return type at the end. C++ and Java would put it at the beginning. Okay, again, you got to know your language. And then there's the set y. Copy, paste. Oops, there we go, set y. All right. The getters. Get x. It takes nothing in it, right? Again, sometimes we put in a void, sometimes not. And it will return an integer. Okay, and then down here, and these also need the colon here. Again, if I miss those colons, again, you would know, oh, that's part of UML. I know what they mean. So there's the set x, there's the get x, there's the get y. Okay, maybe we had some other types of properties. We would have the a toString method. takes in nothing, returns a string. Maybe there was some kind of a implicit print method, and that doesn't return anything, but the printing is done inside that method. Okay, and any other properties that you want to have here. So if you're given a UML, this is enough for you to build it. So it's good in a way that with one little grid like this, you know what the object is and all its different properties. It tells you nothing at all about what to code in here, but at least tells you what to build. Okay, so that's your brief little lecture on UML, and I have to be honest with you, a lot of college classes have 15-week courses on nothing but UML. So you know it goes well beyond this, but this is sufficient enough for what we need to do for our lectures and labs, anything involving object-oriented programming. Okay, bye for now.